Hi there! So in this video, you are going to explore some application of differentiation, and we're going to focus on how to find a rate of change. What is rate of change? Rate of change of quantity will refer to the changes of a quantity with respect to time. For instance, if we want to find the rate of change of quantity of Q, mathematically it is expressed as dQ over dt. In other words, it simply means the changes of Q with respect to time. If the rate is increasing, then the rate of change will have a positive sign. Meanwhile, if it decreasing, then it will be having negative sign. Now, before we dive into the question, let me share you 6 strategies which is more than enough to tackle any question regarding rate of change. ISCDOS, or we can pronounce it as ISDOS. I stand for identify. What we need to identify? We need to identify changing variables, constant variables, and rate of changes of any quantity mentioned. S stand for state, all the equations needed. C stand for chain rule. D stand for differentiate. O stand for obtain the formula to answer the question. And S stand for solve. Now, all of you are geared up to dive into this question. Our first question for today is, water is leaking at the rate of 2 cm³ per second from an inverted hollow right circular cone of height 16 cm and radius 4 cm. Find the rate of decrease of water level when the depth is 8 cm. Let's use the 6 strategies that we have mentioned before. Let's identify the changing variable in derivative form. So that will be the leaking rate of the water. Since it's leaking, so it will be in negative. Also, let's take a closer look at its unit, cm³. So its volume and per second. So we got our derivative form is dV over dt is equal to -2 cm³ per second. Now, let's plot the constant variables. It is given h equal to 16 cm, radius 4 cm, and depth 8 cm. Lastly, for the first step is to scan for any rate of changes of any quantity mentioned, and there it is, the rate of decrease of water level, which is dH over dt. Okay, step 1 is done. So let's state all the equation needed. Since it's a right circular cone and we build our derivative with volume, so let's jot down the formula for the volume of a cone. In order to differentiate, we only need one unknown, but the volume equation has 2 unknowns. So in order to solve this issue, let me introduce you to similarity of triangle. So if we look at the cone, slice it into half and flatten it, and we have our right angle triangle. So we have noticed here there are 2 values for r. One is the unknown itself and also 4 cm, whereas for the height we have the unknown h and also 16 cm. So let's write in a ratio, and then we will get r equal to h over 4. For the next step is to form the chain rule. The question seeks for the dH over dt, and we have been provided by dV over dt. So our chain rule equation is dH over dt is equal to dH over dV times dV over dt. So there is our chain rule. Now to differentiate the equation, we need to do a crucial step in order to differentiate it. Since r equal to h over 4, we can substitute r into the equation and simplify it. Then we differentiate the equation, bring the power to the front and -1 on the power, so dv over dh is equal to pi h squared over 16. But we need dh over dv, so we will inverse it, and dh over dv is equal to 16 over pi h squared. Now, let's obtain the formula we need to solve this equation. As we already get dH over dV and dV over dt, we can substitute them into the chain rule. Now, let's input all the values to solve, which is H is equivalent with the depth provided, which is 8 cm. And let's solve it by keying the numbers in the calculator, and the answer is negative 0.159, and we round it off, so it will be negative 0.16 cm per second.